Alright, today we're going to talk about angles and their measures. Alright, let's define an angle first. So we'll say that an angle that is formed by two non-collinear rays that have a common endpoint. An angle is formed by two non-collinear rays that have a common endpoint. So let's draw a ray. We'll call this ray BA. And then from point B we'll draw another ray BC. So now you've got two rays that aren't on the same line that have a common endpoint B. Okay? So let's put a number 3 right there. Alright, this angle has two sides and a vertex. Alright? Ray BA, the ray that starts at B and it goes through point A, that's called a side. That's a side of the angle. And ray BC, the ray that starts at B and it goes through point C, that's also a side of the angle. The common endpoint of these two non-collinear rays, right here, that common endpoint, it's called the vertex. It's the vertex of the angle. This region inside the angle, this is called the interior of the angle. Everything in here, all of this and everything out here, that's all the interior of the angle. This region outside the angle is called the exterior. All of this blue space, if you were to shade all of this out here blue, that's all the exterior of the angle. So you got a lot going on in an angle. You got a vertex, you got two sides, you've got an interior of the angle, you got an exterior of the angle. Okay? Now there's some different ways to name this angle. So here are some names for this angle. The first name for this angle, you can call this angle, here's the symbol for angle. You can call it angle 3. Since there is only one vertex in this drawing, there's only one angle on the wall right now. You can also call this angle B. You can also name an angle with 3 vertices or 3 points on the angle. You could call this angle ABC. This is real important when you're describing an angle with 3 letters. the vertex letter, the letter that corresponds to the vertex, has to be the middle letter in the description. When you're describing an angle using 3 letters, the vertex has to be the middle letter in the description. You can also call this angle CBA. Does that make sense to everybody? Alright, very good, very good. Turn the page, we're going to look at the top of page 38. Classifying angles. And let's write this down. Classifying by angle measure. So the first angle we're going to draw is what's called a right angle. And when you draw an angle that's exactly 90 degrees, you got to put this little red box in there, where that's what the box means. Whether it's a black box, a blue box, red box, see a little half of a box down there? That means 90 degrees. Let me undo that. I don't want to do that. We want this in here. This means 90 degrees. Alright, a 90-degree angle is called a right angle. And a right angle equals 90 degrees. Second type of angle. That's an acute angle. And an acute angle measures less than 90 degrees. And third type of angle today is going to be called, what's the third angle? An obtuse angle. And an obtuse angle measures greater than 90 degrees. Any questions on any of that? Let's look at the bottom of page 39. Angle bisector. Bisector is a ray that divides an angle into two congruent angles. Congruent means same. symbol for congruent, equal sign with a squiggly line over the top of it. So if you've got an angle this could be angle ABC, an array that divides it into two congruent angles. So I'm going to try to get this ray to divide it into two congruent angles. Call that ray BD. Ray BD in this case would be an angle bisector if you see something like this. These little arc marks. Those arc marks, okay, mean that the two angles are equal to each other. Those little arcs mean that angle ABD is the same as or congruent to angle DBC. Okay? And if you were told, this happens two ways. You're either going to be told that that ray BD is an angle bisector, all right? Or you're going to be asked if ray BD is an angle bisector. So in this picture, is ray BD an angle bisector? It is. And it is because it splits angle ABC into two congruent angles, doesn't it? Alright? Now, if this little arc mark isn't here, now, do you know if you were asked, is ray BD an angle bisector? You don't know because you don't know these angle measures, right? Another way you may see it is like this. Is ray BD an angle bisector? No, it's not, because it doesn't. These two angles aren't congruent. But if you just change this 63, what do I got to change it to? A 62. Now, is ray BD an angle bisector? It is, isn't it? Okay? Alright. What's another way you may see it? What if it looked like this? And you were asked, is ray BD an angle bisector? In order for BD to be an angle bisector, don't the two angles have to be equal to each other? Alright, so could you move along and say that, or try to find out if 2x, let's see, plus 5 equals 3x minus 10? If you set those two equal to each other, that would make BD an angle bisector, wouldn't it? And then what if they asked you to find like the measure of angle CBD? Could you solve for x and then substitute? Okay? And that would give you one of the angle measures. Alright. So that's an angle bisector. Alright, so turn the page. And I just want to go through top of page 41. I want to go through a couple of these examples together, and then I'm going to turn you loose and have you do some practice on your own. So up there in the upper right of page 41, I want you to draw that that little sketch they got there, and it kind of looks like this. And we're going to answer some of these questions together, and then you're going to move on. Alright, so the first question here. If I'm going too fast, let me know. Alright, they ask you to name the vertex of angle 4. So we'll go vertex of angle 4. Any volunteers for the vertex of angle 4? Angle 4 is sitting right here, isn't it? Yes, ma'am. U. U is the vertex of angle 4. Very good. So U. Second question. The sides of angle 3. So I like to, when there's a bunch of angles in a diagram and a bunch of questions related to the same diagram, I like to highlight what they're asking. Alright, they're asking for the sides of angle 3. So the sides of angle 3, I'd take my highlighter out and I would find angle 3 and I would just highlight them. Here's angle 3. And that cleans up this picture for me. Alright, what's one of the sides of angle 3? Yes. Yes. XW? Ray, XW. Remember, the sides of an angle are a ray, are rays. What's the other side of angle 3? Ray. XU, very good. Ray XU. Alright, so those are the two sides of angle 3. Question 3. What is another name for angle 2? Name for angle 2. Well, where is it? It's right here, isn't it? Here's angle 2. What is another name for angle 2? Yes, sir.
Angle Y.
Okay, he said angle Y. But do you see how Y is the vertex for 4 different angles here? When a point is the vertex for more than one angle, you can't just use the one letter. Okay? So be a little more descriptive. What could you name angle 2?
1, 2.
Well, you can either call it angle 2, which they already did. We can't use just the letter Y because it's the vertex for multiple angles. So we got to go with the 3-letter deal. Alright, so we got to use 3 letters to name this angle. So give me that. XYU, angle, X, Y, U. Very good. And one more name for that angle. They already called it 2. Yeah. Angle UYX, good. UYX. And let's take a look at number 4 here. Another name for UXY. Name for angle UXY. And where is it? U to X to Y. Now it's this blue one, isn't it? What's another name for that blue angle there? Yes. Angle 1. Very good. Angle 1. And one more name for it. Angle. Yes. YXU. Very good. YXU. Alright, so you guys kind of get the idea? Naming angles. Let's look down a little bit. Let's draw this next example or diagram for problems 5, 6, 7, and 8. We got kind of this picture here. And then off of this straight line, or off of point F, we got ray FB. Got ray FC, and we got ray FD, and AE is on that straight line. AE, Alright, while you're still drawing, I'm going to read the directions. It says to copy the diagram shown and extend each ray. Classify each angle as right, acute, or obtuse. It then says use a protractor to measure the angle, but we're not going to do that. I don't have enough protractors today, so we'll talk about protractors later on in the week. Okay? So number 5. They're asking you to name these different angles. Classify each. So we got CFD, angle. CFD. Alright? Again, highlight it. Here it is. CFD. It's this black angle. Does that look like it's acute, right, or obtuse? Acute, good. It looks like it's less than 90 degrees. Number 6, ask you about AFD. AFD. We're going to go from A to the vertex F and then over to D. So that angle there, does it look like it's right, acute, or obtuse? It's obtuse, good. So this was AFD, angle AFD, and that is obtuse. And we got BFC. BFC, it's the blue one. BF to C. Anybody? It's right. Why is it right? Because it's what? It's got the box. What does the box mean? 90 degrees. Okay, it's a 90 degree angle, so it's a right angle. And then we'll go with green here for number 8. AFB. Number 8. Angle AFB. And we're going from A to F and back to B. What does that look like? Acute, good, less than 90. Put this on your picture real quick. There's a straight angle in this picture. This straight line right here. The measure of a straight line, that's 180 degrees. Okay? 180 degrees. Any questions? Alright, let me give you some practice problems to do today. On page 41, or starting on page 41, do 12 through 26. And then over on the next page, do 32 through 42, please. And be sure that you check the odd answers.